Dear students, my name is P. Rao, working as a chemistry lecturer in Vignan Cooperative Junior College at Vadlamudi. Today I am going to discuss stoichiometry chapter in first inter chemistry. In the chapter, various topics are: what is matter, what are the various physical states of matter, and what are significant figures, how they are calculated, and what are the different laws of chemical combinations, and what about the mole concept. In mole concept, we have to study the atomic mass, molecular mass, formula mass, etc. And after that, the what is meant by equivalent weight, and then determine the empirical formula and molecular formula of the carbon compounds, and what is meant by stoichiometric calculations, how to express the strength of the solutions in various expressions, and what is meant by oxidation and reduction, how the redox reactions takes place, how to calculate the oxidation number values, and how to balance the redox reactions by using oxidation number method and half reaction method, and what are the redox reactions in titrometry. So these are the topics in this stoichiometry chapter. Now the first topic in the chapter is properties of matter. Matter means anything which has some mass and occupies some space in the universe is said to be a matter. Generally, matter exists in three physical states. One is solid, and other one is liquid, and third one is gas. So matter exists in three physical states. Among these three, in solid, the atoms are very close to each other. Intermolecular forces of attractions are more. That's why solid having some definite volume, and definite shape also. That means in solid state, the atoms are having intermolecular forces of attractions. That's why they have some definite volume and definite shape. And the liquids have some definite volume. They have some definite volume, but not having definite shape, because the shape of the liquid is equal to shape of the vessel or container. So among these two, when compared with the solid state, in liquid state, intermolecular force of attractions are less. So they have some definite volume but not having definite shape. The shape of the liquid is equal to shape of the vessel or container. But in the case of gas, they have neither shape nor volume, because in gaseous state the intermolecular forces of attractions are very weak when compared with solid state, liquid state. That's why gases have neither shape nor volume. The shape and volume of the gas is equal to the shape and volume of the vessel or container. So generally matter exists in three physical states: solid, liquid, and gaseous state. So solids having definite volume and definite shape, Liquids have definite volume and the shape of the liquid is equal to shape of the vessel or container. But gases, in the gases, the molecular force of attractions are very weak. That's why they have neither shape nor volume. So the shape and volume of the gas is equal to the shape and volume of the vessel or container. So the matter is divided into pure substances and mixtures. Pure substances means element and compound. For example, helium is one of the element in the periodic table. This element containing the only helium atoms. So they are the pure substances in the matter. Similarly, compound. Compound means it contains two or more different elements in a definite ratio. For example, carbon dioxide is a compound. Whatever it may be the source, carbon dioxide always contain 1:2 ratio of carbon and oxygen. That means element and compound are the pure form of the matter. What is an element? It is the simplest form of matter which cannot be further divisible into simpler substances. That's why helium is one of the element in the periodic table. Compound means group of different elements. Here carbon dioxide is one of the example of a compound. It containing carbon element and oxygen element. So these two are the pure form of the matter. Another form of the matter is mixtures. So mixtures means two or more components. If two or more components are mixed together, if they form homogeneous mixture, that is one of the example of the type of the mixture. For example, sugar solution. Sugar is dissolved in water. Now that is one of the example of homogeneous mixture because two components are in a homogeneous form. If they are in heterogeneous form, that is known as heterogeneous mixture. For example, salt and sugar are the examples of the heterogeneous mixture. So finally, matter is converted into two forms, pure form and mixture form. Element and compounds belongs to pure forms of the matter, and the mixture means if it is in homogeneous form or heterogeneous form. So this is about the classification of the matter in stoichiometry. Now the next topic is significant figures. What are significant figures? Significant figures are meaningful digits which are known with certainty. There are so many rules which are used to find out the number of significant figures. The first rule is all non-zero digits are significant. For example, if the value is like this 2, 3, 4, how many significant figures are present in 234? 234 value means one of the rule in the calculation of the number of significant figures is all non-zero digits are significant. So here these three are non-zero digits. That's why for 234 number of significant figures is equal to 1 plus 1 plus 1. That means number of significant figures in 234 is equal to 3 because all non-zero digits are significant. And second rule is if the zeros are preceding to the first non-zero digits, they are not significant. If 0 is present preceding to the first non-zero digit, for example, if this is the value 0.002 value, in this value, two zeros are preceding to the first non-zero digit value. That's why for 0.002, the number of significant figures is equal to 1. Very, very important bit. Because according to second rule, the zeros preceding to the first non-zero digits are significant or not significant. That's why these two are not significant figures. Only this is the significant figure. That's why 0.002 having only one significant figure according to that rule. Zeros preceding to the first non-zero digit are not significant figure. Now the third one is, if zeros are present in between the two non-zero digits, now they are significant. For example, if it is this value 2.003, now here in this value two zeros are present in between the two non-zero digit values. That's why they are also countable. So this is 1, 2, 3, 4. So 2.003 having 4 significant figures, because in this rule the zeros are present in between the two non-zero digit values. That's why they are significant. Here these two zeros are not significant. So that is the difference between the second and third rule. Now the next rule to calculate the number of significant figures is, if the zeros are at the end or right of a number are significant, provided they are on the right side of the decimal point. That means if you take this value 100, two zeros are at the end of this value, but these two are insignificant. So 100 containing only one significant figure. If you write like this 100 point, now these two zeros are becomes significant. That means 100 point having three significant figures. Remember that 100 having only one significant figure, because 0 at the end or right of a number are significant provided they are on the right side of the decimal point. Suppose if you write like this 100.0, now this value having how many significant figures means it has 1, 2, 3, 4 significant figures, because 0 is present on the right side of the decimal point. That's why this 0 becomes significant. Now here this point makes these two zeros becomes significant. So in 100 there is only one significant figure. 100 point shows three significant figures. 100.0 shows 4 significant figures. And the next rule is, while counting the number of objects like the 20 balls, for example, it is equal to 20.0000 and so on. That means these balls are having infinite number of significant figures. While counting the number of objects, they have infinite number of significant figures. And very important rule while calculating the number of significant figures is, in numbers written in scientific notation, all digits are significant. For example, Avogadro's number value is equal to 6.023 into 10 power 23. Now here the zeros are in exponential. 10 power 23. Now this becomes insignificant. According to that rule, in numbers written in scientific notation, all digits are significant without 10 power something. So 6.023 containing how many significant figures means 1, 2, 3, 4. So very important IIT JEE main bit is Avogadro's number has 4 significant figures because Avogadro's number value is written like this in exponential form 6.023 into 10 power 23. Similarly, velocity of the light c is equal to universal constant value c is equal to 3 into 10 power 10 centimeter per second. Here also this is exponential value, so this becomes insignificant. Now velocity of the light, for velocity of the light, significant figure is equal to 1. Significant figure is equal to 1. So these are the different rules which are used to calculate the number of significant figures in this chapter. Rounding of the significant numbers. If the rightmost digit to be removed is more than 5, if you want to rounding of the significant numbers, if the rightmost digit to be removed is more than 5, the preceding number is increased by 1 unit. For example, 3.0126. If you want to remove the last number, that means 6, round off this significant number value, it is more than 5. That's why one number is added to the preceding number. So the answer becomes 3.013 because the last digit is more than 5. If the digit is less than 5, now the preceding number is not changed. For example, if this is the value 2.023 and 4, for example, if you want to remove the last digit 4, here it is less than 5, that's why the preceding number is not changed. So the final answer for this value is 2.023. So if the last digit is more than 5, the preceding number is increased by 1 unit while rounding off the significant numbers. If the last digit is less than 5, now there is no change in the preceding number value. So 2.0234, the last digit is 4. If you want to remove this digit, it is less than 5. That's why the preceding number is not changed. So the final answer is 2.023. If the last digit to be removed is exactly equal to 5, now the preceding number is not changed if it is an even number. If it is an even number, for example, 6.125. In this value, last digit is exactly equal to 5. If you want to round off this number, now this value is exactly equal to 5. Now the preceding number is not changed if it is an even number. So here 2 is an even number, that's why 6.125 is nothing but 6.12, because here the preceding number is even number. If it is odd number, for example, that number is increased by 1 unit. For example, 7.135. See this value. In this value, last digit is exactly equal to 5, but the preceding number is odd number. That's why 1 unit is increased by 3. So the answer is 7.14. So this is also very important point. If the last digit is exactly equal to 5. If you want to remove that number, if the preceding number is even number, there is no change in that number value. If it is odd number, add 1 unit to that number. That's why 7.135 is nothing but 7.14. Now, if you add or subtract the significant figures, the rule is the result cannot have more digits to the right of the decimal point than that at the original number, which has the least number of digits to the right of the decimal point in it. That means, see this addition here. For example, it is 13.012, one of the value. Another value is, for example, 1.2. Another value is 4.02, for example. Now add these three values. There are three values here. By adding these three values, actual answer is 2, and this is 3, and this is 2, and finally this value is 18.232. But this is not the correct answer here according to significant figures calculation rules, because in these three values, after the decimal in the first value there are 3 digits. In the second value, after the decimal point there is only 1 digit, and here in third value after decimal point there are 2 digits. Now answer should be, after decimal, that answer should contain only 1 digit, because in 1.2, after decimal point there is only 1 digit. Now your answer is also like that, but here in your answer after the decimal point there are 3 digits here, but among these 3 values the least number of digits are present in second value, which is equal to 1. So your answer is also like that. That means you have to remove these 2 values by using round off method. So one of the rule in round off the significant figures is, first remove this value, because in second value after decimal there is only 1 digit. Your answer is also like that according to this significant figures calculation rules. So first remove this 2 from this answer. So it is less than 5. It is less than 5. That's why there is no change in the preceding number. So the answer is 18.23. And once again remove this number 3. It is also less than 5. So the preceding number, there is no change in the preceding number because this last digit is less than 5. So the final answer is 18.2. That is the meaning of addition and subtraction. Follow the same concept in the subtraction of the values also. So if you add these 3 values, the actual answer is 18.232. But this is not the correct answer, because in the second value after the digit it has only 1 value. So your answer should be like that only. That's why round off these 2 values. Here this is 2 is less than 5. That's why preceding number, there is no change in the preceding number. And once again this is also less than 5. So there is no change in the preceding number. So the final answer is 18.2. And then in the multiplication and division of the significant figures, the result must be reported with no more significant figures as there in the measurement with the few significant figures. For example, 2.5 into 1.25 is equal to 3.125. If you multiply 2.5 with 1.25, the final answer is 3.125. But this is not your final answer, because in these two values, in the first value 2.5, the number of significant figures is equal to 2. In the second value, number of significant figures 1 plus 1 plus 1, 3. So your answer should be like this. That means in our answer in 3.125, number of significant figures is equal to 4. But in 2.5, number of significant figures is equal to 2. In 1.25, number of significant figures is equal to 3. Now the final answer should contain total number of only 2 significant figures. Here there are 4 significant figures. That's why apply the round off rules. Here, if you want to remove the last digit, here it is exactly equal to 5. So apply the rule. If the last digit is exactly equal to 5, preceding number is even number, there is no change in that value. So this is equal to 3.12. But in 3.12, total number of significant figures is equal to 3. Now remove this last digit. Apply the rule. Here 2 is less than 5. That's why there is no change in the preceding number. So the final answer is 3.1. So these are the different rules which are used to calculate the significant figures. So up to now, properties of the matter and how to calculate the number of significant figures by using various rules are completed.